Mercury is the planet nearest to the Sun in our solar system. Mercury's surface on its day side is hot enough to melt lead. The planet has a diameter about 40% larger than that of the Earth's moon. During the second episode of our 13-part series, Journey Through the Solar System, we will examine the planet Mercury in detail. I'm your host, Larry Ross, Director of Space Programs at NASA's Lewis Research Center in Cleveland, Ohio. Before we begin our examination of Mercury, we will preview the planetary lineup for our following shows so that you can see how Mercury fits into the picture. A NASA film called Our Solar System was made to aid young students. I think you'll enjoy seeing the short film, which introduced youngsters to the order of the planets in our solar system.
My very educated mother just served us 9 pizza pies. My very educated mother just served us 9 pizza pies.
My very educated mother just served us 9 pizza pies. Let's see, there are 9, the 9 first letters of those 9 words. And there are 9 planets, with Mercury closest to the Sun and Pluto furthest away. And in between,
my very educated mother just served us 9 pizza pies.
Mercury is the smallest. Venus is about the same size we are, but the resemblance quits there. Its atmosphere is 10 times as dense as ours, shrouding the surface completely. And the average temperature is the boiling point of lead. And Earth, well, that's us.
My very educated
Mars. How about Mars? Through Earthbound telescopes, we can watch Mars turn greener by seasons. Watch what might be polar ice caps advance and recede. Does that mean Mars has a summer and winter? Earth telescopes develop questions. Photographs from spacecraft like Mariner are beginning to supply answers. But man, do we still have a lot to learn. Hey, NASA!
My very educated mother, J.
J is for Jupiter the Giant, 300 times the size of Earth. Its atmosphere is a lethal smog of ammonia and methane and hydrogen. Likely there are fantastic lightning bolts flashing all through it. But you know, that's almost the same combination our Earth had a few billion years ago. At about the same time, early forms of life appeared. Did you know that Jupiter has a big red spot on it? It's oval-shaped, as wide as Earth, and 3 times as long. And it shifts position on the planet in a mysterious way. Why? Questions.
My very educated mother just shoved it up.
Saturn has those rings, and we've measured them. They're more than 37,000 miles wide, but only about 6 miles thick. Then comes Uranus and Neptune. Jupiter, Saturn, Uranus, and Neptune are called the 4 giant planets, but Pluto is puny and cold. So that makes 9 planets spinning around our sun, one of 100 billion suns in our single galaxy. In turn, one of 10 billion other galaxies.
My very educated mother just served us 9 pizza pies.
The word planet is derived from a Greek word meaning wanderer. Planets were called wanderers because they were observed to change their positions relative to the stars. The planets of our solar system are divided into two main kinds. Gas giants are the planets Jupiter, Saturn, Uranus, and Neptune. They are composed mostly of gases. The other category of planet is the terrestrial type. Earth is in this category. This does not mean, of course, that the other planets in this category closely resemble the Earth. The terrestrials are those planets of the inner solar system which are small and rocky. Current theory suggests to us that the Sun and planets formed from the collapse of a big cloud of dust and gas about 5 billion years ago. The center of the cloud compressed to make the Sun. Planets formed in orbits around the Sun. The theory also suggests that the inner planets are relatively small and rocky because they originated from a hotter part of the dust cloud where much of the gas was lost. Mercury, named for the Roman messenger god, is denser than the Moon and seems to have a large iron core. Mercury was only a blur in Earth-bound optical telescopes until NASA sent the Mariner 10 probe on 3 flybys of the planet in 1974 and 1975. Incidentally, Mariner 10 was launched by the Atlas Centaur rocket managed by Lewis. Now, here are excerpts from a NASA film entitled Mercury, Exploration of a Planet.
There is a small planet so near the Sun that it is scarcely visible in the bright glare of our star. Like an elusive ghost, it is best observed from Earth in the twilight hours, when the sun is gone from the sky. The ancient Romans gave it its name, Mercury. So little was known about the planet that scientists could only guess at its origin and evolution. Like the planet Mars, it could have had violent volcanoes, deep canyons scarred by violent winds, or like our own moon, its surface might be pitted with craters, a record of ancient events written on a planet's surface. The best photographs of Mercury added little to our knowledge. But when man learned to travel in space, the electronic cameras of a spacecraft called Mariner 10 revealed the planet in startling detail. In June of 1975, scientists from 5 nations assembled at the California Institute of Technology to exchange the information they had gained from the exploration of the planet Mercury by the spacecraft Mariner 10. Included in the group were scientists representing many techniques of exploration, including the detection of various forms of radiation, the study of gases in a planet's atmosphere, and the powerful scientific tool, photography of the surface of a planet.
Welcome to Pasadena. We are convened.
The photographic exploration of Mercury was led by Dr. Bruce Murray of the California Institute of Technology.
The objective I have is to present a relatively simple interpretation of the history of Mercury and to draw some conclusions about the other terrestrial planets.
The work that Dr. Murray and his colleagues are engrossed in goes beyond the exploration of a single planet, Mercury. They are seeking insights into the history of our entire inner solar system. In March of 1974, Mariner 10 flew past Mercury. During the next year, it would perform 2 more flybys.
Mariner 10 returned almost 3,000 pictures of the surface of Mercury. These pictures reveal craters and other features which were formed very early in the history of Mercury and may refer to events that affected the entire inner solar system, Mars, Earth, Moon, and Venus, as well as Mercury. The pictures of Mercury reveal craters and many other features. And to the geologist, these features and these pictures are like the pages of a history book. And the history book for Mercury may go back almost to the formation of the solar system itself.
"5 billion years ago, a vast cloud of gas and dust floated through the galaxy we call the Milky Way, the ghostly remains of a great star that had died in a gigantic explosion. The gas and dust is twisted and shaped by magnetic forces, electrical currents, and the subtle pull of gravity. As it swirls around a thickening core, the huge cloud gradually flattens into a disk. Dust and gas gravitate slowly inwards, and eddies begin to form in the cloud. Particles of matter cluster into solid bodies. The larger bodies continue to grow, sweeping up particles and dust as they orbit the condensing core of the disk and begin to heat under the increasing gravitational pressures. In the central core of the disk, incredible heat is being generated, hotter and hotter, until it reaches critical temperatures. And then, billions of years ago, a nuclear reaction occurred, and our sun was ignited. Its intense radiation repels the surrounding gas and dust. The increasing heat of the inner planets has formed them into molten spheres. Mercury, like the other inner planets, is continuously bombarded by debris that form craters on its surface. In the final stages of its formation, Mercury glowed from internal heat. Hot lava was forced to a surface being torn by collisions with masses of rock that were shaping the planet. The same heat that triggered the lava flows also melted rock and metals in the interior of Mercury. Heavy iron concentrated at Mercury's center to form a dense core, which was overlain by a thin shell of lighter material brought to the surface by lava flows. Again, the surface was gouged and pitted by a great series of impacts, leaving huge craters on the surface. The Mariner 10 photographs have revealed these early craters to scientists for the first time. One of these craters was formed by a massive rock, perhaps a small planet that crashed into Mercury. In the Mariner 10 photographs, half of this huge crater was hidden on the night side of the planet. Today, this huge crater is called Caloris. The impact spewed millions of tons of debris across the surface of Mercury, creating a ring of mountain ranges over a mile high. The floor of this basin was split by great surface cracks, wide and deep. As this surface continued to form, Deep inside Mercury, its heavy iron core began to contract. The surface buckled, cracked, and great sections, hundreds of miles wide, were split open, leaving immense mile-high walls of rock called scarps. Again, there was a great flow of lava covering many of the large craters and leaving smooth, flat plains. This set the stage for the final episode in the history of Mercury, a period of light cratering of the Great Plains. In this time, Mercury died. The internal heat that triggered many of the events in the planet's history turned off. And for 3.5 billion years, Mercury has remained as we see it today.
Before Mariner 10, there were a multitude of possible Mercuries. Now there's only one, the Mercury of craters and basins and plains. And this illustrates how photography can be an exploratory tool. It displays features which were perhaps never even anticipated and then sometimes could not even be imagined before the experiment was flown. In a sense, it provides answers to questions that were not even asked. This was true at Mars when Mariner 4 returned pictures of what appeared to be a moon-like surface. It had been expected that Mars might be very much like the Earth, with folded mountain ranges and many other Earth-like features. Instead, it looked like the moon, and that was a big shock. And it was an even bigger shock when Mariner 9 in 1971 visited Mars again and found huge volcanoes and even some peculiar sinuous channels that looked like they might have been formed by flowing water at some point in Mars's history. Now Viking has transported man's vision to the actual surface. The fantasy of science fiction has been replaced by the strange, lonely reality of the Martian landscape. When Mariner 10 flew by Venus, it discovered an unexpectedly well-organized set of cloud motions. And the unexpected was certainly encountered in the case of Mercury, which turned out to exhibit not only moon-like features on its surface, but a sequence of events there that seemed to be very similar to those of the moon. And that's extraordinary, because Mercury is very different inside compared to the moon. And that means it must have had a different history of heating and modification of the surface from the inside. And furthermore, it lives in a very different part of the solar system, much closer to the sun. And therefore, it must have experienced a different exterior history as well. And yet, the pictures show that Mercury has a surface history very similar to that of the moon. And to me, that's extraordinary.
A comparison of the craters on the Moon, Mercury, and Mars shows that these inner planets were subjected to cratering at the same time. Before Mariner 10, it was believed that the source of cratering of the inner solar system was the asteroid belt orbiting beyond Mars. Because of the difference in distance from the belt, it was assumed that no two planets would be cratered the same. Those planets farther from the asteroid belt, like Mercury, would have fewer craters. But a careful count of the craters on Mercury and a comparison with those on the Moon and Mars showed them all to be roughly equal. If the crater count is equal, then the source could not be the asteroid belt, but must have come from elsewhere in the solar system. One strong possibility is the planet Jupiter, with a gravitational attraction second only to the Sun. It is possible that on 2 occasions, Jupiter literally hurled millions of tons of rock inwards towards the Sun to impact the planets of the inner solar system, including Mercury. This cratered record on Mercury was read 3 times because of a fortunate coincidence. Mercury's orbit around the Sun is 88 Earth days. Mariner 10's orbit was twice as long, or 176 days. These synchronous orbits allowed Mariner 10 to fly past Mercury a second and third time. The path of the first flyby was on the dark side of Mercury. The second encounter sent the spacecraft past the light side of the planet specifically for photography. After another 6-month journey around the sun, Mariner 10 made its third and final encounter to look again at a major discovery made during the first flyby: the presence of a magnetic field around Mercury, similar to Earth. A bow shock wave blocks the solar wind from the sun and deflects it around the planet, creating an environment similar to the magnetic field around Earth. This discovery was a surprise because Mercury's slow rotation, about once every 57 Earth days, had led scientists to believe that the planet could not generate a magnetic field. It is believed that Earth's magnetic field is generated by an interaction between the planet's faster rotation and its molten core. Mariner 10's discovery may change theories on how these fields are formed and has given scientists their first opportunity to compare two magnetic fields in the inner solar system. There were other measurements made at Mercury by Mariner 10. Infrared showed that Mercury's surface ranges in temperature from 700 degrees Fahrenheit to 300 degrees below zero, the widest temperature range of any planet. The ultraviolet experiment revealed that Mercury has a very thin atmosphere of helium. Sensors measured the invisible cosmic rays which flood our solar system at tremendous speeds, penetrate any surface, and are unaffected by gravitational forces. Their source is unknown.
Exploration is an adaptive process. Each new piece of information adds to the value of others that were accumulated earlier. We had the results of the Apollo program on the moon to help us understand the timescales and to some extent the processes we were seeing when we looked at Mars with Mariner 9. Now that Mariner 10 has looked at Mercury, we can begin to compare it with the moon and Mars and begin to realize that there is a common solar system history which has been recorded on these planets, whose early surfaces have not been erased by erosion and other atmospheric processes. That same common history affected the Earth too. And so by looking at these surfaces, reading those records, we're in fact looking back into the Earth's history, into a heretofore unexplored domain of time, our own history on the Earth. Now we can begin to compare and contrast, to look for similarities and differences, and try to recognize our family relationships among the terrestrial planets. Are we cousins or brothers, or are all of us bizarre strangers that happen to inhabit the same portion of the solar system? That's the task of comparative planetology. That's where we go from here.
What we know about Mercury comes, for the most part, from the Mariner 10 mission, which we just saw described in the film. Mercury looks much like the moon. However, on Mercury, there do not seem to be dark deposits of lava, which covered the moon 3 to 4 billion years ago. About half the planet was photographed by Mariner 10 during its 3 flybys. Before 1965, scientists thought Mercury always kept one side facing the sun. But after radar measurements of the planet done by astronomers at Arecibo Observatory in Puerto Rico, Mercury was found to rotate once every 59 Earth days. The rotation speed at its equator is only 6 miles per hour. Earth's rotation speed at the equator is about 1,000 miles per hour. Mercury's orbit is an egg-shaped ellipse compared to the nearly circular orbit of Earth. When Mercury is at its nearest approach to the Sun, the orbital speed increases. This change in orbital speed causes Mercury to keep one face toward the Sun during this close-in approach. Later, when Mercury moves farther from the Sun, the planet's rotation changes the face that sees the Sun. Because Mercury gets as close as 28.5 million miles to the Sun, the planet becomes very hot on the day side, as much as 950 degrees Fahrenheit. At the same time the day side is hot, the night side of Mercury is as much as 346 degrees Fahrenheit below zero. Mercury's gravity is about a third of Earth's. The gravity of the planet Venus was used to slingshot the Mariner 10 spacecraft to Mercury in 1974. Mariner 10's primary mission was to Venus, the second planet from the Sun. Using the gravity of Venus to deflect the spacecraft to Mercury was the first trial of this method. As we will see in a later program, the Pioneer and Voyager spacecraft also used a gravity assist to fly by several planets in the outer solar system in a grand tour. Jupiter and Saturn have already been flown by, and a Voyager craft is on the way to Uranus and perhaps Neptune. Spacecraft have explored more than 20 planets and moons. There is a planned progression to the study of our solar system. The first step is what we have seen in this program, an unmanned flyby of the planet. Next comes unmanned spacecraft which orbit and land on the worlds. The last stage is manned landings and the return of samples from the planet to Earth. This last step has, of course, as yet happened only on Earth's moon. This is Larry Ross saying goodbye from the NASA Lewis Research Center in Cleveland, Ohio. I hope you can join us for the next program entitled The Veil of Venus.